Lesson 22, modeling circuits. We'll be able to model circuits. So it's just going to be, today's just going to be a lesson about modeling circuits and having a little bit of a play around with them. We're going to be analyzing them, but we're sort of going to be taking a bit of an easy route when it comes to analyzing them. Let's go back to what we did last time. Last time we talked about energy. We talked about power and energy. We talked about this new formula, E equals VIT, which means if you know the voltage, you know the current, you know how long it's been on, you can calculate the energy. Now, energy is one of the, in physics and in engineering and science, energy is one of the most important things. Energy is great because it means it's one of those concepts that goes from different topics. If you work out how much energy something has in light, you can work out how hot it can make the piece of water. You can measure how high you can lift the ball with that much energy. You can work out how much Big Macs that you need to supply that same amount of energy. Energy just can be used in, like, you can even work out how much light do you need to have this much energy. So that's why we love to use energy in so many different parts of our calculations. So that means that's what E equals. And the other form, of course, is energy equals power over time. Equals power multiplied by time. Because power is, let's talk about power. Power is V times I. Or it can sometimes be known as power equals energy over time. How much energy is there per second? So if I've got a 60 watt light globe, that means that light globe is emitting 60 joules of energy every second. That's what 60 watt light globe is. If I've got and so energy per second, that's where power comes from. But instead of saying energy per second, we just say watts, because whatever. What we did is, after we learned those two equations, we applied them, and then we talked about kilowatt hours. It's just being another way to do it, but instead of using watts, we used kilowatts. And instead of using something like minutes, we used hours. And then we would be able to solve it in either joules or kilowatt hours. And then that was the end of the lesson. I actually let you go. I did it again. And then that was pretty much the end of the lesson. Then I let you guys go. I let you guys go early. My wife was very confused. She's like, don't you guys have stuff to do? I'm like, no, I let my students go a little bit early. This is the last thing we did, was we talked a bit about efficiency. So that, well, what's the most efficient way to go from point A to point B? Stuff like that. We said that efficiency is the useful energy. So if you're like making burning coal to make electricity, that's your electricity is going to be useful energy divided by the total amount of energy that you release, or the total amount of energy that you use. If you're talking about, like, I don't know, a solar panel, the total amount of light that hits the solar panel over how much of that light is turned into electricity. If you're burning coal, how much of it turns to electricity versus heat? You know, even if you're like something like, if you're making a motor move, how much of it is moving the motor and how much of the energy is wasted to other things? So today we're going to take a little bit of an easy sort of route. We're going to try and model some circuits. We're going to take a little bit of a rest. We're just going to do a quick little modeling circuits kind of like animation, kind of give it a try kind of scenario. I'm going to explain what I'm going to get you guys to do in just a second. Before we do that, I wanted to talk to you about this. This is a plan, okay? So I'm going to be honest with you guys, because I usually am. It's like quarantine has just been messy. It's been very weird and difficult, and it's just been, especially my project. So what we would do now is, like, what this lesson would be, normally, instead of modeling circuits, what we would do is we'd be doing electronics 4. Then in Thursday, what we would do is we do revision. But that's obviously not what we're doing today. That's not what we're doing. We're doing electronics 4. Now, what I'm kind of thinking of doing is that I'm thinking of doing is letting students work on, and then after we would have done that, we would have then jumped on and done the electronics project. But because we're at home and we're not at school, it kind of means we haven't been able to do the electronics project. So I've been trying to figure out for the past couple of weeks what to do. Then I sort of thought, I know what I'm going to do. And then that whole thing got put a spanner in the works. And they said, guess what? We're going back to school week 9. And so therefore, I'm like, okay, we can do an electronics project. I thought, wow, we actually get 3 weeks of electronics project. That's more than I normally get. The reason why there are so many here is because there is no exam. Because there's no exam, that means we get week 11 back. It also means we get week 10 back. Because week 10 is normally for exam revision. So now we have 2 weeks at the end where I thought we might as well give the electronics project a try. We might not be able to get through all of it, but we could get through some of it. So what I've got in the middle here is gray. The next 3 weeks are kind of gray because this is subject to change. I'm not 100% certain that this is what I'm going to do. What I guess I thought would make sense would be
So can I quickly say something?
Sure, you can.
So does that mean there's no exam for the elective stuff?
I've been told so far, this is my understanding so far, note that it's subject to change, but I'm pretty sure that there will be no exams for any, there's pretty much going to be no exams for anyone aside from Year 12s. And those Year 12s are going to do the exams during the holidays. Even Year 11, so I teach Year 11s, they've actually said to me, it's like, it's up to you whether or not you want to do an exam in your class or not. So I think it would be my understanding. Now, you don't listen to me. Don't listen to your random elective teacher.
I'm quoting you. I'm going to quote you.
God damn it. Thanks a lot, Angus. Don't listen to your random engineering maths teacher of an elective that you only do 3 times a week. You should listen to your coordinators that are in charge. But
sir, I know you.
My understanding is that there is no exam, but that's just at the moment. It could change. They could say, you know what, we thought about it. We actually want to do an exam anyway because we want to know where our students are at. In which case,
that's so mean, though.
Yeah, I know. No. That's why it's very unlikely that it's going to happen. I think pretty much the curriculum authority of the curriculum committee, which is a bunch of teachers that are in charge of stuff, I've said it's going to be no exam. So anyway, my theory is there's no I'm running on the assumption there's no exam. So that means we get a couple of weeks at the end of the course left. But the problem that I have is that, well, I can't jump from where we are now. We can't start doing the electronics project because we're at home. But I also have this problem was like, okay, well, what do I do? So my theory was my current plan, which is subject to change, that's why I left it in gray, is to do this. I want to spend 3 lessons next week talking about voltage dividers. Now, voltage dividers are a part of the course that I had in my engineering maths course for a long time. And I only took them out, and it gives you a little bit more practice with electronics. I only took them out, and they're really quite, in my opinion, they're pretty easy because there is a formula that works for them really well. I only took them out because I wanted more time to do the electronics project. But now that we can't do it, I thought maybe I could spend 2 lessons doing that, a double here and then a single period here, just doing voltage dividers, with revision being on the Thursday, for an electronics test. Now, the reason I don't want to push the electronics test into week 9 because that's just, another 2 weeks away. Plus, it means that, we lose one of our very first lessons that we finally get to actually do something with our hands and practical. Oh, actually, no, I want you guys to do a test. That seems like a waste. I might as well do a somewhat okay test, an online test. Now, the rest of these 5 lessons that I've got here before the lockdown ends, these are kind of like, I guess, a little bit filler lessons, but I thought maybe we could use that time to talk about what the project is, get you guys.
What a project?
Yes. That's
Oh man.
Sorry, sir. He's too concerned. He just texted me that he's upset that we can't change our names. So he's more focused about that, which is very understandable.
Than on the actual thing. Yeah, okay, fine. Anyway, doesn't matter. I'm moving on. The point is that those are the 2 things that I'm going to be focusing on. I'm thinking that's what we could start on. And I'll sort of tell you, it's more of a robotics project rather than an electronics project. For sure, a robotics project.
Mister, is that a group thing or a single?
It'll be a group thing.
Oh yeah.
So that's
Angus.
You're saying.
Yeah, you're a part of Angus.
So that will be the robotics project.
I'm going with Jeff.
All right, hey, come on, guys, focusing. So that's when I thought, I could give you guys the brief. We could get you guys to maybe pick what groups you guys would like to be in and stuff like that, and we'll go from there. Then I'm thinking, part of the project is about 3D modeling, so maybe I could spend some time teaching us 3D modeling online, which is something we can do, even though we're in lockdown. You guys can access it. Of course, you got a crappy laptop, maybe you might not be able to do that great a job, but it should be able to do an online 3D modeling. We'll see how that goes, And then I was thinking maybe the last day before the end of lockdown is to go through some basics of coding. Obviously, I can't go through in-depth coding, but yeah, go through some basics, and then that would lead into the rest of this topic. Now, this gray stuff is sort of in flux. In flux meaning that it can sort of change. What I want to show you guys is just one more slide here. Voltage dividers, this is what I'm thinking about doing it. Why I'm thinking about doing voltage dividers is it closely relates to the circuit theory we've just been doing. Okay, but I wanted to just put this up here. I'm going to say, if you guys have got an idea, so I'm going to put this grm@Braybrook. This is my email. .vic.edu.au. If you guys have an idea of maybe something that you would like to learn in engineering next week, and you're really passionate about it, you think it'll be a really good idea, then I want you maybe to send me an email. Okay, don't call it out now, or don't write it in chat, because I'm probably not going to check it. But you send me an email and I'll have a look. I'm thinking of doing voltage dividers next week, just because it relates to circuits, and it's pretty easy to do, and it's not a great big jump. But there are some other ideas. In the past, I've done numerical skills, like scientific notation, significant figures, and unit conversion. That's another option I could do. I could very easily do that because I've got the pages for that already. And so that might be good, because it might give you guys some help, especially if you guys are doing one of those. Either you've done those things already in maths, or you want to learn them so you can get better at doing them in maths. Maybe we could do that instead. These ones here I've never taught before, but maybe there's something we could do. Maybe instead we could look at, I've always wanted to spend a lesson talking about torque, which is about like motors and how motors work. And that sort of links back to our idea of what we talked about with vectors. Stress and strain, I felt that might be something that's material properties. Why do we build bridges that look like this? Why can't we just build bridges that look like this? You know, there is a reason for that, you know? And I thought that would be a good idea too. I've always wanted to talk about that with the class because I'm like, it's very closely related to, it's sort of related, it's very engineering based. It's like, how do we solve a problem? How do we build a bridge? And it does still link to maths and does still link to vectors. So stress and strain. The other one is investigating it in, like, we could look at like a particular marvel. We could look at coal fire plants. We could look at weirs. We could land dams. We could maybe look at like like a car. We could look at an electric car. We could spend our time studying one. Like we could spend a week, so 3 lessons looking at one of those things, and then spend one lesson looking at one of those things, and then a single period maybe answering questions about it. At the moment, I'm going to let you. Yeah, hold on. Yes, is it about
Instead, can we do what?
Yeah, go.
You know Logan Paul's cool bus. We did that
No.
instead.
We're not doing anything about Logan Paul. Why would you say something like that? No. Like, I feel like giving you an F just for bringing up the name Logan Paul.
Anyway, why not Jake Paul's link?
Okay. Anyway, the point is that I'm currently, and as I said, I don't want you guys to say it out loud now, but I'm currently going to stick to the plan that next week we'll do voltage dividers. But if any of these things are like, oh my God, no, Mr. Greer, please, no, I desperately want to know more numerical skills. I desperately want to, because I've got a class on that. You know, maybe I have to do significant figures for biology and I really want to know what it is, or I don't know. Maybe like I've always wanted to know what stress is. Like, why do they keep talking about mechanical stress? What does it mean? If you're desperate to learn one of these other things, send me an email, tell me why you want to learn it. But otherwise, I'm just going to go with voltage dividers. I'm giving you guys a chance. If you want to shout out your student voice, then maybe I will consider it. But at the moment, that's my plan. So this is the plan for the moment. Okay. It is subject to change a little bit, but yeah. Now, today, I'm going to show you what we're going to be doing. Today, what we're going to be doing is a little bit different. Where is it? Go back to the attendance question here. Oh, come on. Okay. So what we're going to be doing today is I've sort of set this task here. This task here is a circuit building activity. Now, what I've sent to you guys each is a folder that looks like this. And in that folder, there is a bunch of random questions. And it's all based off this. Let me see if I can. Did I not give you the link? Oh my God, I'm such an idiot. The link to the website. Oh my God, I didn't give you the link. Oh, I'm a moron. Okay, hold on. Am I sharing the right page? Yeah, I'm sharing the right page. Let me give you the damn link. Here is the link to the website. Oh my God, I'm an idiot. I think Reese pointed it out. Reese was like, "We have the link," and I'm like, "What do you mean? Like, cool, got the link." Let me. Where do I put it? Where can I put it? I'm going to put it in the description. Here is the link. I'm going to add. You know what? I'm going to add a link as well. Look at that. Look, I'm just going to make it just so easy for you guys to get to this link. Beautiful. So hopefully, Reese figured it out though. Reese, you're the best. Thank you, Reese. Are you even on the stream, Reese? Because I'm like, you haven't answered the attendance questions. So I'm like concerned that you're not even here. Yeah, Reese isn't even here. I don't know what Reese is doing. Like Reese is having his own wild adventure, I think. So yeah. Unless he's here, but he's hiding and he's changed his name. Okay, so what I want you guys to do is we're going to be spending a fair bit of time in this interactive simulation. Now, this is a simulation of a circuit because guess what? We can't use the actual circuits in the school because we are in lockdown. So let's go have a look at what we can do. In this situation, we can take a battery, we can take a wire, we can take a light bulb. Let's take 2 light bulbs actually. I can join this. I'm going to make it look pretty because, you know, I'm like that. You know, you don't have to do these extra wires, but yeah, I'm going to do them. I'm going to join 1 wire, bang, bang, 1 wire, bang, bang, and then 1 wire, bang, bang. Look at that. Hey, we've got light globes. They're both shining. This is a series circuit. Now, I can change each of these components. I can click on this wire, I can click on this, and I can crank up the voltage. Let's crank it up to 12 volts. Let's make it a 12 volt. Let's make it a 12 volt battery. And I can flip the battery. Notice how the electrons change direction. If I look at it, if I click on the top here, instead of showing the electrons, let's look at the conventional current. Remember, that comes out of the positive and into the negative. So yeah, I can just flip it and change the current. If you don't like that, you can actually turn it into, down here, the bottom right, turn it into circuits. And I love this program. Is just really, even though it's a very simple looking program, it's actually pretty sophisticated. Now, both of these light globes have the same voltage drop because they're the same resistance. How can I measure the voltage drop? Well, good thing I've got a voltmeter here. So if I put my voltmeter on, because I'm measuring in the wrong direction, it says -6 volts. I'm going to flip this around. So now I know the positive side is this. Yeah, this is the positive side. So this is the red wire. This is the negative side. This is the negative wire. It goes there. 6 volts. If I measure now this one over here, it's also 6 volts. And I can measure the current. Current's a bit harder to measure though, because in order to measure current, you got to break the circuit. I'm going to break the circuit. I'm going to twist it. I didn't even know I could do that. I'm going to give you. Bam, here we go. The current is 0.6 amps. Now let's play around with this just a little bit. Now let's go through this. Even though, now this is the thing I keep telling you guys, even though this comes first, the current hits this light bulb first, we can see that it still drops 6 volts. And this light bulb comes second. And you think, oh, well, it has less energy. No, it still drops 6 volts. Let's start playing around with it though. Let's crank up the ohms. Let's crank this up to 20 ohms. Let's try that. Let's make it 30 because 30 was easier for me to get to. Now with 30 ohms, we can see now we still only have a 12 volt resistor. So now this is dropping 3 volts. It used to drop more, whereas this is now dropping 9 volts. And we can actually see that this light globe is brighter. We can see here now the current has dropped. You can tell that by 2. 1, this number here is now 0.3 instead of 0.6. Whereas before, and also you can tell that these arrows representing the current are moving a lot slower. So by increasing the resistance, by making it harder for the current to go through the light bulb, we actually have made it more, by making it harder for the current to go through the light bulb, we've meant that it drops more voltage. It has to drop more voltage. It has to use more energy to get through that light bulb. So therefore, if it's dropping more voltage, it releases more light and looks brighter. Now watch this. If I switch the direction of the current, this one's still a brighter light bulb because it's still going to need more energy to drop over this light bulb. Okay, Now, what else have we got in our arsenal? We've got resistors. We've got a battery that's a, this is a high voltage battery. You probably don't need to use this one. You've got a fuse. We haven't talked about fuses before. Fuses are kind of cool. How a fuse works is that if a, let's create it. Let's turn this into a bit of a, what, I don't know, series circuit? Yeah, here we go. Series circuit ahoy. What a fuse does, if you want to play around with a fuse, is that when it reaches a certain voltage, that fuse will, when it like exceeds a certain voltage, that fuse will die. We can measure to see, this is now conducting 0 volts, probably because I haven't connected something. Maybe I need to crank up the voltage. Let's crank up the voltage and see if I can. I don't know why. So now, if I build up the voltage too much, I think what will happen is that fuse will. Man. If I crank up the bang, okay, I blew up the fuse. So the fuse breaks because that's what a fuse does. It's designed to break rather than destroying the rest of your circuit. And yeah, so I can maybe reset the fuse. I don't know. We can turn this down to like 100. Can I reset it? Yeah, there we go. But watch, if I start cranking up the voltage, eventually, bang, it pops the fuse. There are a couple, these things here are high capacity resistors. Then you got a bunch of things you can experiment with instead. So you can experiment with, does a coin conduct electricity? I don't know, maybe it's made out of metal, so probably. Does a paperclip conduct electricity? Does a dog conduct electricity? Don't ask. I don't know why they included that. So, and then once you've got like a circuit that you're happy with, you can print screen this guy and then copy that, and then you can just go, oh, I'm not sure if you saw me push that, but I can then go, yeah, I'm going to put this in here, put a screenshot in. And so Control V, screenshot, done. All I want you to do is make your way through this document. You've got about 10 minutes to do it now. You won't get through all of it, so maybe spend some time tomorrow. And then tomorrow I'm going to give you guys circuit 4.